Okay, so now we're on to page 2. And page 2 is going to start with this question. Identify the vertex and the y-intercept. So we know the vertex is our start point, because every single time we've looked for these quadratics, we looked for a slope and we looked for a start point. And so we don't really care about the slope right now. We care about this start point. So when I look at this, I'm going to figure out where this graph would start at. Well, the 1 tells me it would be left 1, and the -2 tells me it would be down 2. So this is what I get from it. So my start point would be -1, 2. Well, that would be my vertex. My y-intercept would be this part of the graph, or where it crosses that y-axis, which I know what that would be because if I look at all the x values, like if you're counting through all the x values, this would be like 1, 2, 3, 4, 5. So the x value for this one is 0, because 0, 1, 2, 3, 4, 5. So we know the x value of this is 0. And if I know the x value is 0, to find a y value, all I would do is plug that in. So I'm going to get 3, 0 plus 1 squared minus 2. Well, 0 plus 1 is 1, so that's 3 times 1 minus 2. So 3 minus 2 is 1. And that would be my y-intercept. So my vertex is that start point, and they tell me the transformations. And then I find my y-intercept by just plugging 0 into my equation. Let's do the next one. Now for this one, we'd like to put it into vertex form. So to do that, what I'm going to do is I'm going to write what vertex form looks like, which is y equals blank, and there my slope goes in, blank, and there my x value goes in, and blank, and that's where my y value goes in. So my slope for this one, I can see that it's just 1 from up there. And then we need to find the vertex, or the start point, to find our x value and our y value. So to find the vertex, how we've been doing this is -b over 2a. My b value is -4. My a value is just 1, so that's 2. So my x value that I'm going to get is -2. Now if I have an x value, how I find a y value is I plug that into there. So that's going to be -2 squared plus 4 times -2 plus 2. Which that's going to give me 4 minus 8 plus 2. And 4 minus 8 is -4, and plus 2 is -2. So my x value and my y value are here. So we'll plug the x into here. And remember, when we plug the x in, it's always opposite. And then we're going to plug in the y value. So my final equation would be this. Okay, let's do the next one. My next one has a ball thrown upwards from ground level. It has a height of h feet and it is above the ground in t seconds, and we're given this equation. Well, I always try to find what I'm doing, and what I'm trying to find is a max. And then I always think about what is another name for a max. Well, that would just be the vertex. We've found a lot of vertexes so far, so how do I find a vertex? Oh, I do -b over 2a. My b value would be 64, so that's -64 over 2a. My a value is -4, so 2 times -2. And we're going to get -64 over -4, which is going to leave us with, oh, whoops, I plugged that in wrong. It's 2 times -4, so that's -8. So we're going to have -64 over -8, which is just going to give us a +8. That's what's going to go in for our x. Now after we find the x value, to find the maximum height the ball is going to go, or that y value, I have to plug that back in. So when I plug that back in, I'm going to get -4 times 8 squared plus 64 times 8. So that's going to end up giving me negative 1, I should double check this, because that'd be 8 times 8 times 4, so negative 256. I think I checked. Whew. Sometimes it freaks out after you lose the pen. Plus, and I'm pretty sure that's 500 something, but we will double check again because I have been known to make mistakes. So 64 times 8. Yep, that's 512. And 256 minus 512 is going to give us 256. So again, for this one, what you want to look for in the word problem is the keyword, which is max. And then you know how to find a max. It's negative b over 2a to find the x value of your vertex. Plug that in to find the y value, and then you have your answer. Let's do the next one. Okay, so we've been given what looks to be a quadratic function, and we have to decide some things. So the first thing we have to decide is this linear or quadratic? And you can decide that very easily because a linear function, when you graph it, makes a line, and a quadratic function, when you graph this, makes a U-shape. And when I look at this, I go, oh, it's going to be shifted to the left or right 3. It's going to be shifted down 4. And it's going to have a slope of 2 over 1. And because it has a squared, it's going to make that U-shape. So this is a quadratic. Now, when they talk about the quadratic linear and constant term, this is my A, this is my B, and this is my C. And normally we have it in this form. Now you might go, well, how is this form different than the other form? And the difference is this right here is in vertex form, and we would like it in standard form. So we have these parentheses, and we don't want the parentheses there. So what we're going to do is we're going to undo that by timesing it by itself. So we're going to undo that by timesing it by itself, or squaring it. So we're going to get y equals 2 x squared minus 3x plus 9 minus 4. Then I'm going to get y equals, and we can combine these together to give us negative 6x, and then we'll distribute that 2 to everything, which will give me 2x squared minus 12x plus 18 minus 4. And then our final thing will be y equals 2x squared minus 12x plus 14. So our a term is going to be 2, our b term is going to be negative 12, and our c term is going to be 14. And this will be my answer to this problem. Okay, so we got one more to do on this page. So make sure, again, when you're reading through things, you want to try to think about like what they mean instead of trying to memorize how to do everything, because there's a lot of different techniques for this test. This is the last problem on the first page, and what we want to do with this is we want to convert this thing to standard form. So how you'd end up doing this is you would say that we have some quadratic, and we don't know what the quadratic equation is. So when you have some quadratic and you don't know what the equation is, it's generally easiest to say that it's in this form. And because I know it's in this form, I can plug in some information. Oh, my y value for one of the points is 0, and my x value is 2. So I could say 0 equals a 2 squared plus b times 2 plus c. Oh, for my second one, 5 equals a times 1 squared plus b times 1 plus c. Oh, for this last one, 2 equals a times negative 3 squared plus b times negative 3 plus c. And this is the system that will find the quadratic equation for this problem. Now there's two different ways we could go about this. We could solve this system by doing the elimination, where you eliminate these two and eliminate these two and find your final answer. That's going to take us a while. So I'm not going to really go about it that way because I think that's going to be a little bit more complicated. We have learned earlier that you can do this with matrices, so I'm going to just make this into a nice matrice. So the nice matrice that this would make would be 4, 2, 1, 1, 1, 1, 9, negative 3, 1. times, and our variables are A, B, and C in that order. And this would be our answer 0, 5, and 2. And then our calculator can do all the heavy lifting with this. We know that we're going to take the inverse of this one, and we're going to take it to the other side. So our final answer is going to be like this A inverse times our B. So I'm going to plug all that info in my calculator. Going to edit A, and it's a 3 by 3. That's 4, 2, and 1. 1, 1, 1, 9, -3, and 1. And then I'm going to go to my matrix, and I'm going to go to B. And this is a 3 by 1. That's 0, 5, and 2. And then we're just going to go matrix A inverse times matrix B. And there's my final answer. So those aren't too, like sometimes you're going to get some decimals, but those aren't even too bad of decimals to get. So you'd have y equals -1.55 x squared. I think the next one was -1.55 also, plus 7.7. And that would be your final answer. So again, it's not too bad to do this problem. Just plug in all the variables, and you make your matrices, and then you can solve your matrices using your calculator. Okay, that's the second page. If you needed any help on the third page, I'm going to do that video next.